Anna, and this presentation is to show you all the concepts in grade 12 chemistry that are related to anesthetics. First, I'm going to define what anesthetics are and show you some examples of anesthetics. Anesthetics are a group of different types of drugs that cause loss of consciousness. These drugs are generally administered by an anesthesia provider to induce or maintain general anesthesia to facilitate surgery. Different anesthetic drugs have various levels of strongness. For example, some of them are very strong and some others can only make you feel clumsy or even happier. There are two different types of anesthetic drugs that can cause unconsciousness. First, gases and vapors, and secondly, injections. These anesthetics have helped surgeons a lot and obviously made their life easier. For long surgeries and for surgeries that the patient must remain unconscious the whole time, injection anesthetics are used at the beginning and then gas anesthetics are used for the patient so they can remain unconscious for the whole time. There are many different legal and illegal anesthetic drugs. These are names of some legal anesthetic drugs. From the gas type of anesthetic, there is nitrous oxide, which is the most popular one, and then there are desflurane, sevoflurane, and isoflurane, which are mixed with nitrous oxide to help patient remain unconscious. From the injection type, there is propofol and etomidate. I'm going to give you a bit of more information on nitrous oxide because it's my main focus. A nitrous oxide is commonly known as a laughing gas or sweet air. At room temperature, it is colorless and non-flammable gas with a slightly sweet odor and taste. It is known as laughing gas due to the euphoric effects of inhaling it. Now that we have a basic background on what anesthetics are and where they are used, I'm going to introduce you to three concepts of chemistry that we learned this year and are related to anesthetics, especially nitrous oxide, which is a significant type of anesthetic. All the connections that we have are related to chapter 3 and 4 in our chemistry book. Firstly, I'm going to talk about the type of chemical bonding in nitrous oxide. Secondly, how the elements in nitrous oxide react together and their shape before bonding, which is related to chapter 3. Lastly, shape and polarity of this molecule and the intermolecular forces between them. As you know, we have three different types of bonding between elements. There is ionic bonding, which takes place between metals and nonmetals. Then we have covalent bonding that takes place between two or more nonmetals. And lastly, there is metallic bonding, which is a bond between different metals. NO2 or nitrous oxide is produced after a reaction between oxygen and nitrogen, which are both nonmetals. This means the bonding between them is a covalent bonding. Covalent bonding have different properties from ionic bonding. In ionic bonds, the nonmetals gain electrons from metals, though in covalent bonding, the two nonmetals share the electron between them. The sharing of electron can cause the two nonmetals achieve the stable shape and also the bond to stabilize. But before this bond to take place, we need to know how do nitrogen and two oxygens share electrons so that they are both happy with electron sharing. Nitrogen is in 15th family and oxygen is in 16th family of periodic table. This means that for nitrogen to stabilize, it needs 3 electrons and oxygen needs 2. Nitrogen has a total of 7 electrons and oxygen has 8 electrons. So the electron configuration for each of them is going to be looking like this. For oxygen, it is this, 1s2, 2s2, 2p4. And for nitrogen is like this, 1s2, 2s2, 2p3. Now we only need the last unfilled orbital for the reaction to take place, and we are going to use the Lewis structure to see how does this work. NO2 has a resonance shape. It can either have this shape or this shape. This means that the electron is being shared can vary in different molecules, though it doesn't flip from in one molecule to one shape to another. Using the VSEPR theory, we'll know that NO2 has a linear shape. It doesn't matter which kind of bonding it has. I mean the two bondings that I told you, but it's gonna be linear. And since it's a gas, there is no intermolecular forces between the molecules. So if they meet, they're just gonna push away each other. And so this is all my presentation, and I hope you enjoyed. I'll see you later. Bye.